So where I teach, I require my students to follow very specific best practices. And particularly when it comes to surface modeling, I want my students to manage their surface data very, very carefully. So the best practices I teach my students may not be the same best practices used out in the industry. It's probably not the same best practices used by anybody else, but they are best practices, and I expect my students to adhere to them. So I want to introduce what I refer to as a Solidify group. So a Solidify group is essentially leads to a final surface that's going to be solidified into a body. So I'm going to jump back to the part design workbench. I'm going to create a body, and I'm going to call this solid. How's that for creativity? I'm going to call this solid. Now I'm going to jump back to or move back to the generative shape design workbench. So I'm going to create a geometric set. This is going to be named solid. So notice the commonality here. So this is a non-ordered geometric set called solid, and I'm going to end up solidifying a surface into the body called solid. So for my students, I have required them, this is going to be referred to as a solidified group called solid. So I'm going to create 3 more geometric sets, and these are going to be sub-geometric sets. So the first one is going to be called solid wireframe. This geometric set will be the holding place for, or where I organize the wireframe entities that lead to surfaces. Next, I'm going to have a solid surface, and notice I keep that singular for a reason. And this will be where I create surfaces and where I perform operations on surfaces. And then finally, solid, which is the Solidify group name, in my example at least. Solid references, and these are where I keep essentially anything else. It could be points, could be even reference surfaces, but really anything else that's not a solid that would be solidified, nor a wireframe entity, to include sketches that will lead and create a surface. So one thing I have my students do is they will create an access system for every Solidify group. So this is the Solidify group, and I've just happened to name this one solid. So I'm going to create an access system, and I like to have my references subgeometric set activated, because if I decide I would like to put in let's say an origin point for my access system, it will be placed under here. So as an example, if I go and insert and I do an access system, and then let's say that I would like to define the origin of my access system, I can, in context in this example, create a point at, let's say, 0, 0, 0, and now I've got a point defining the origin of my access system, and that point is located here. And sometimes if I get really picky, I may have my students name it access system or something like that, just so they can find it and know what it's there for. So access system point. So that's an example of something that goes under references. So for anything that's wireframe oriented, to include sketches, I will put under a wireframe. I'll throw out something here really, really quickly. I like to do position sketches. So let me throw out a real quick sketch. And I'll keep it simple, simple, simple. Let's just do a circle. Doesn't get much more complicated than that, does it? So I got a circle going on here. So that actually needs to be in the wireframe geometric set. I always forget to move stuff around. I tell my students I stop every now and then and move stuff where they need to be. So that's an example of a wireframe entity. So I moved it to the wireframe geometric set. Now let's just create an extrusion of this so I can activate my surface subgeometric set, and let's say I do an extrusion of it. Again, I'm going to keep it simple, so that's the surface. Now let's say that I want to fill it. do a fill here, and let's even do some tangent support there. And so there's something tangent oriented looking. So there's right now I've got two visible surfaces. So in the end, I need to perform an operation, some type of operation, something to get that down to one surface, because you can only solidify one surface at a time. So I want to join those two together. And what I tell my students is, under the surface subgeometric set, I only want to see one visible surface, and I would prefer it to be the last one. These are non-ordered geometric sets, so it doesn't have to be, but I prefer it that way. This would be the surface that ends up being solidified into the solid. So when I come back here, I like to use the solidify options in the part design workbench. So I'm going to go back to the part design workbench. I'm going to activate that body. And I do tell students that if you're only doing one solidify, it doesn't have to go in a body by itself. You can just do it under part body if you wanted to. So you can put it here, or you can put it under part body. Since I'm not doing multiple solidify groups, I'm just doing one solidify group. It would be fine under part body as well, but I'm going to put it here for now. So I can go, so I'm in the part design workbench. It's going to go in here. So I can go insert, surface space features, and let's just do a closed one on this one. And there's my closed solid, and it's in a body. And if you don't want the surfaces showing, you can just hide either this geometric set, or you can hide the surfaces, but don't hide hide only geometric sets. Don't hide surfaces. So I can hide that, and there's my body that's been solidified. So that's an example of my very, very basic example of how I teach the organization of geometric sets within CATIA Generative Shape Design Workbench, when it's doing, of course, when I'm doing surfaces that I will solidify into a body. Thank you.